couple different ways. This was the one where I said, meanwhile, sales of homes in the foreclosure process rose 4.28% to 4,600. And assuming about 50,000 sales in that should be the last 12 months, how does Oregon's overall foreclosure rate? This is actually Oregon as a whole. This was not the first two were Bend. This is Oregon overall. So now what I'm trying to do is I'm trying to do something that doesn't happen effectively very often, comparing Bend to the rest of the state. Very often Bend is trying to be compared to the rest of the state, I think ineffectively. For example, they talk about cost of living in Bend. And they say, well, the CPI in Portland. Like, time out. Portland could not be more different. Well, it's very similar to Bend in a lot of ways, like they're in the same state. But I mean, as far as like cost of living, you can't just assume they're the same because they're in the same state, right? So we have to be careful. So here's one way of analyzing it. We've now analyzed Bend. Here's Bend in 2013. Let's look at how Oregon compares. So what did you guys do? Tell me what you did with this. You can ignore that 4.28% actually if you want, because that 4.28%, I have no idea where they got it from. Many times they'll say, very often you hear things like, sales of electric cars doubled in the first 6 months of 2020. What they meant was it went from 20 to 40. I mean, and that doubled, it's doubled, right? But when you look at that as an overriding proportion of the car sales that happened, it didn't change at all. 20 out of however many cars got sold in the first 6 months of it. So I don't know where that 4.28% came from. And hopefully that wasn't the numbers you guys looked at. So tell me what you did.
One prop Z in.
Boom! Little one prop Z in again, yes. The standard error we set on the board, let the machine crank it for you. So let's do it again, make sure we're all on the same page here. These are handy little machines to have. I got plugs, here we go. It's climbing. All right. Boom, boom, boom. You see that? Nah, not really. Put it over here. Slide this up a little bit. That way.
You can still have frame shots of your face every once in a while.
Yeah, I got a good one from you guys on Monday. That one graph was up with the big bell curve, and I was standing like this. And it took a snapshot at that moment. I'm like, that's perfect. And then a few other ones where I was like, so, you poor people have to deal with this every friggin' morning.
We should start that off in our morning.
It's just a good pace.
Slideshow.
This is, well, it's capturing it right now. We'll have to see what the roulette wheel of the camera is later on. So, where are we going? Stat. Tests.
All the way down to A.
All the way down to A. Yes, or alpha math. Good, very nice. Very nice. One prop Z and get in focus, please. Look, we're still set from last time, I think. So this time, Michael, I'm sorry, what did you tell me you put in?
The X would be 4,600.
Thank you, sir. And the N was? Right, I truncated that off using Zillow. I just figured how many homes were for sale at that period of time. Okay, we're going to cut. Here we go. Check it out. Let's use a different color. Let's use blue. All right, so here's Oregon at roughly the same period as Bend was here. What do you notice? It's having my voice cracking. Boom! So 8.9% to 9.5%. It's like here to here. So this is Oregon 2013. So all three intervals are alike. How? Right, B hat is essentially identical for all three of them. But just because P hat is identical, that could be random chance. Yeah, I mean, every time we draw a P hat, it varies a little bit because of the whole idea of sampling error. So, again, why so narrow? Huge! 50,000. As a matter of fact, some people might even say, did I even draw a sample? Or did I actually, assuming that Zillow, the site that I pulled this off of, was accurate in their listings, might I actually have captured the entire population of for sale homes? Might I have? Might. Michael's saying no, you didn't. Probably didn't, you're right. But assuming that Zillow is listing all of them, and I pulled that number from their website, I got the population, didn't I? So could actually legitimately argue that you could just say Oregon's foreclosure for sale rate is 9.2% and walk away at that. You wouldn't technically have to put a margin of error on there, would you? Assuming that I got all the houses in there. That's an assumption. Now, if you want to play it safe, should you? Yes. Slap the margin of error on it and say, you know, there might be a few more houses out there that I didn't get. And chances are you didn't, because I'm sure with the way houses turn over in this state, that not everyone makes it onto the site every day. So you can't go wrong, and this is back to whoever asked about margin. Ray, you asked about this before, right? About the margin of error that I quoted of 9 or 6 or 7 or whatever. When you are given those percentages, okay, like when they say the unemployment rate used to be 5%, now it's 6%, or the unemployment rate used to be 7%, now it's 5%. I don't know where those numbers came from. Are they parameters? Did they actually take every claim that came in? I don't think so. I wouldn't think so. I think it's more of a sample than a census. So in other words, if they don't give you a margin of error, you have a couple choices. This is a great question, because this is going to happen to you guys when you process the news for the most part. It won't happen in scholarly journals very often, because if they don't put margins of error in scholarly journals, they don't get published. But in the news, when they give you a statistic and say Obama's approval rating is now below 50% for the 3rd time in a month, you can just go to Gallup, where the poll was housed, and look at the bottom and find the margin of error. Just because the news doesn't report doesn't mean it's not there. They don't report it because they're not trained to report it, because they have to keep news going 24 hours a day. So they have to fill it with all kinds of stuff, some of which is misleading. Potentially. Go.
Before when you did the confidence interval of 95 for that, is that because you're comparing them so both of them are 95%?
Very good question. 95% is fairly standard. It's fairly standard. Watch what happens if you change the confidence. Thank you, Renee. Great question. It's not a very good answer. I apologize for that. But we tend to use 95% confidence. I want to delay your question a little while until we understand what error looks like. But it's fairly standard. Watch what happens if we change the confidence level to something higher like 99. Now, we know what effect this had on the margin of error calculation, because we did it in class yesterday. The margin of error is just that standard error, but there's a z multiplier out front. So essentially, when you change confidence, you're changing that z multiplier. You're making it larger in this case. So look at the effect it has on the overriding interval. What happened to it? It got a touch wider. It got a touch wider. It went from 8.5 to 9.4 to 8.9 to 9.5 or something like that. So it got a touch wider. If you lower, go ahead, ask me that question. I thought I heard a question. I'm hearing things. I don't senile age. You can lower confidence. So suppose you want to go to 1, a margin of error of 1 standard error. Not that you would do this, but let's do it right now because we can. You would change your confidence level to what? It's essentially 2/3, right? Or 68% or something along those lines. All right, now watch you look at your interval now. We've now lost the 8%, and we're at 9% and above. So you can see how the conclusions would be different, right? The conclusions would now be different. If I asked you the question, can you conclude that the for sale foreclosure rate, or the foreclosure for sale rate, whatever we're calling this, was above 8% for any of these right here, these guys right here, or above 9%, not above 8, above 9%. For any of these right here, you can't make that conclusion. Because in every one of those intervals, 9% is in the interval, but so are some values below 9%, yeah? But as soon as you lower the confidence far enough, all of a sudden, 9% pops out of the interval. And the lowest this one gets is now 9.1%, doesn't it? Let's put another one up there, yellow.
So essentially,
what
that blue box up there is like its own little bell curve, and that's just where the 95%.
Yes! Very good way of thinking about it, actually. Hold that thought, Michael. So yellow is at 68 or 62/3 confidence.
I guarantee you can't see that on video. Yeah.
Oh, and then let's write an orange. Or red.
Just thinking of people who are.
Yeah, thank you for thinking of those people. That was good. Thank you for the people that have muted me on their video. I gotta take the video, so not his voice. Here's Oregon in 2013 at 2/3 confidence. It's only the red one, have you noticed? It's only the red one that happens to me with. What the hell? What's that?
So you start recording it, and figure out the frequency of which numbers.
I don't have to, it's 100%. So if you're happy with 2 out of every 3 of your intervals actually catching your parameter, by all means use that. That doesn't seem very, 2 out of 3, that's kind of bad. So but if you demand more than that, if you demand the 95%, well, look at the difference in the widths, yeah? Look at the difference in the widths. And that's a function of that bell curve, as Michael said, the tails shoot. You gotta go out pretty far to catch more and more area. 1% of area, depending on where you are on the Z-scale, could take you a far, far distance Z-score wise. So here we go, boom, and this one here was state color coding. There we go. This guy here is at 95% confidence. So coming back, I haven't forgotten your question yet, Michael, I want to get back to it. Coming back to Renee's question, 95 is fairly standard for 2 reasons. One of which is it minimizes, well, as best as it can, what's called a type 1 error. But it also does a decent job of knocking down what's called a type 2 error, which confidence intervals don't even talk about yet. That's why I'm going to hold back on it a little bit. It's the same reason, I'll give you something to think about. Anybody ever been to Yellowstone National Park?
Yep.
Okay. What geyser did you go to at Yellowstone? The big one. Old Faithful is the name, yeah? No, it's not the biggest one.
Well, it's
It's the most regular
It's not the most regular. There's one called minute or minute, and I forget, I don't know how you pronounce it, but it's literally this big. And it goes off like every minute. Like every minute it's like, and then it's like, oh, I missed it. But they'll just stick around 57 more seconds and it'll pop again. But it's this big. And then Old Faithful is a large geyser. It's a good size, it's 130 feet or something.
Yeah.
But there's one called Texas Geyser, of course, that's much bigger. Much bigger, but it goes off like every 5 years. And then sometimes it'll go off every 5 years and then pop like 45 minutes later and blow it again. It's like 400 feet tall. But it's not very regular. Old Faithful, because as hence the name, is fairly, every like 90 minutes I think it goes off. And it's pretty big. It's 130 feet tall. I'm not saying it's small, but it's not the biggest, nor is it the most regular. But it's the perfect blend of the two. And that's kind of 95% confidence. It's the perfect blend of minimizing both kinds. It's the Old Faithful of confidence levels. More mathematics to follow on that, I promise you that. Go, Harrison.
There's a picture of my grandpa Harrison in the lodge right there.
Uh-huh.
Putting a log in Old Faithful.
Oh, in that lodge.
Like before the 30s.
Yes.
Yeah, he's a dishwasher there.
Yes. I used to ask the question, why do so many people go to Old Faithful? And then somebody responded, because they built a road right to it.
Yeah,
That's
right there.
It's a brilliant answer. Why did they build the road right to it? Hence what we just discussed. They built a lodge right next to it, they built a road right to it. They didn't build a road to minute, guys. You gotta hike across the desert to get to it. Because it's adorable.
Probably why it's so like famous too is like back in the day you could like put something.
Well, they've ruined, some of them ruined because of that. They're throwing coins into it. People didn't know any better. They thought it was like a wishing well. Anyway, so back to Michael's question. Each of these things do have a bell curve. Yes, they do have a bell curve. This one is wider and shorter than this one because of standard error changing. These two actually have the same bell curve, don't they?
Yeah.
Because they're based on the same sample size. It's just that this one is chopping less of the bell curve than this one is.
But basically, so what I was kind of getting at is that the outside edges are showing where the 95%
Or this 2/3. Exactly. That's what I'm saying. The exact same thing in a different way. Yeah, there's a bell curve attached to every single one of these. Let's come back to that actually. And some of you might be wondering, that's a perfect observation. Some of you might be wondering, why are we talking about bell curves at all? Like, these are binomial things, yeah? These are binomial things. Why are we talking about bell curves? Because bell curves are z-scores, which are part of these margins of error calculations. So this part of it looks like a bell curve, and that part looks like binomial. So I have, I think, a decent answer for you. It's